All right, well, welcome to the class. Um, Today we're in chapter 3, physics 101 class, and we're looking at vectors. If you have been following our online class, we have done chapter 1 and 2 so far. Chapter 1, we looked at systems of measurements, and we broke it down from beginning to the end. The video is still on the channel there. Chapter 2 was what we did yesterday, finished it yesterday. We took 2 days to finish chapter 2 because it's long, kinematics. Everything about motion, free fall motion, projectile motion, the one that has to do with when you differentiate and when you integrate. We did all that and we finished chapter 2. Now we're in chapter 3, vectors. So please, class, come with us. Let's learn vectors. Let's learn vectors together. Let us learn vectors together. So you're all welcome to the class. So class, let's start with vector representation. Right now, our first subheading is vector representation. Vector representation. Vector representation. Vector representation. Class, we're all aware that in physics we have 2 types of quantities. We have scalar quantities and we have vector quantities. We have scalar and we have what? Vector quantities. We have 2 types of quantities in physics. We have scalar quantities and we have vector quantities. We all know that scalar quantities from our foundation in secondary school are quantities that have magnitude but no direction. Scalar quantities are quantities that have magnitude but no direction. While vector quantities are quantities that have both magnitude and direction. So class, in this chapter, we want to be studying vectors. Now, first of all, before we understand vectors, we must understand what are examples of scalar quantities, quantities that have magnitude but no direction. What are examples of scalar quantities? Examples of scalar quantities is speed. Speed is a scalar quantity. Distance is a scalar quantity. Distance is a scalar quantity. Energy is a scalar quantity. Energy is a scalar quantity. These quantities have magnitude but no direction. Area is a scalar quantity. Area does not give you direction. Volume is a scalar quantity. Density does not have anything to do with direction, just magnitude. All these quantities are what scalar quantities. They do not have direction. Why am I starting from here? Because even in your exam, I've seen questions where they say, which of the following is not a scalar quantity? Which of the following is not a vector quantity? Now, for vector quantities are quantities that have both magnitude and direction. And we have velocity is a vector quantity. Acceleration is a vector quantity. Force is a vector quantity. Class, when you're applying a force on a body, you need direction. Where are you applying the force to? You can't just apply force anywhere. Force is a vector quantity. Displacement is a vector quantity. Displacement is a vector quantity. These are vector quantities. So we have just introduced you to scalar and vector quantities. Scalar and vector quantities. Class, momentum is a vector quantity. Momentum is a vector quantity. Momentum is a vector quantity. Class, is temperature a scalar or vector quantity? Temperature, is it a scalar or vector quantity? Temperature is a scalar. Have you ever been given temperature and you're given direction before? No. So temperature is a scalar quantity. No, that's not direction. That's not what you mean by direction. Mass is a scalar quantity. Mass is a scalar quantity. Class, mass is a scalar quantity, but weight is a vector quantity. But weight is a what? Because weight is the force of gravity acting on an object. So it's specific. Mass is a scalar quantity, but weight is a vector quantity. Mass is a scalar quantity, but weight is a vector quantity. Class, pressure is a scalar quantity. Pressure can be applied anywhere. Pressure can be applied what? Anywhere. So pressure is a scalar quantity. Now, class, having explained to you scalar and vector quantities, the next thing we want to look at now, as we said, is vector representation. Vector what? Representation. Class, write down vectors can be represented in 2 dimensions and 3 dimensions. Vectors can be represented in 2 dimensions and 3 dimensions. Vectors can be represented in 2 dimensions and 3 dimensions. Class, in 2 dimensions, when vectors are represented in 2 dimensions, that means we are talking about only the x and y components. 2 dimensions considers only the x and y component of the vector. 2 dimensions considers just the x and y component of the vector. 2 dimensions considers just the x and what? Y component. And we all know that the x component represents the horizontal component, right? Horizontal component. The y component represents the vertical component. The y component represents the vertical component. So x represents horizontal, y represents vertical. X represents horizontal, y represents vertical. X represents horizontal, y represents vertical. So in 2 dimensions, we have x and y. In 3 dimensions, we have x, y, and z. Class, in 3 dimensions, we have what? X, y, and z. We just talked about 2 dimensions. Now in 3 dimensions, class, if you're talking about in 2 and 3 dimensions, in 3 dimensions, we have x, y, and z. This 3 dimensions. These 3 dimensions. Class, the x dimension is any vector on the horizontal axis, on the x-axis. This is the x dimension. This x. The y dimension is any vector on the y-axis. This is y. Any vector on the y-axis. And the z dimension is the diagonal dimension, z-axis. Z. So we have x, we have y, and we have z. We have x, we have y, and we have z. Don't forget, the x-axis is the horizontal axis, the y-axis is the vertical, and the z-axis is the diagonal axis. Class, each of these axes has both their positive side and their negative side. Class, this is positive x-axis, this is the negative x, this is the positive y-axis, this is the negative y, this is the positive z-axis, and this is the negative z. This is the foundation of vectors, class, in your Phys 101. This is your foundation of vectors in your Physics 101. So each axis has both positive and the negative dimensions. Class, but I'm sure you must have been saying in your questions, maybe assignment or even your classwork or in class, whereby they are not using x, y, and z, they're using I, j, k. Lecture is using I, j, what? K. Class is simple. The x is the I, y-axis is j, and z-axis is what? K. So class, the x component represented with I, the y component is j, and the z component is k. Please take note. So anytime you see I, j, k, it means x, y, z. I, j, k. So in 2-dimensional vectors, only I and j are mentioned. So if you are given a vector A equals to 2i plus 3j, it means that this vector only exists on the x and the y dimension. But if you are given another vector B is 3i plus 4j plus 5k. This is a three-dimensional vector because it exists on the x, the y, and the z axis. Are you following? So the three-dimensional vector exists on the x axis, the y axis, and the z axis. Now, coming back to the two-dimensional vectors, or three-dimensional vectors as the case may be, the next thing we need to look at now, please write down addition and subtraction of vectors. 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 Addition and subtraction. So we have shown you how vectors can be represented as under vector representation. It's now time to teach you addition and subtraction of vectors. Let's write it up here so we can have more space. Addition and subtraction of what? Vectors. Class, let's look at an example. Given the vector, let me actually take a real question so that you can work with something serious. Given the vector A equals 2i minus 3j plus 4k, and B equals I plus 2j minus 3k. So given the vectors A equals 2i minus 3j plus 4k, and B equals I plus 2j minus 3k, and C equals 3i plus 6j minus 4k, and C equals 3i plus 6j minus 4k. And we're asked to calculate calculates 1, A plus B plus C. Calculate 1, A plus B plus C. 2, 2A minus 3C. 2, 2A minus 3C. 3, A plus 2B minus 4C. A plus 2B minus 4C. D. 3. 4. Sorry, 4. This should be 3. This is 1, 2, 3, 4. Question 4. 3B minus A plus C. 3B minus A plus C. 3B minus A plus C. Class, addition and subtraction of vectors. Addition and subtraction of vectors. Is this for you? Okay. Class, let's get to solving these questions. Let's get to solving these questions. Class, first question said A plus B plus C. Class, and our A is 2i, minus 3j plus 4k. Our b is I plus 2j minus 3k. Our c is 3I plus 6j minus 4k. And they say find a plus b plus c. A plus b plus class. A plus b plus c. Class, one thing you should note about addition and subtraction of vectors. When adding up vectors, similar vectors should add up each other. Similar vectors should add up each. What I mean by that is that I should add up I here. J to J to J, K to K to. I doesn't have any business with J and doesn't have any business with K. J doesn't have any business with I, doesn't have any business with K. So I from A should add up I from B, should add up I from C. J from A should add up J from B, should add up J from C. K from A should add up K from B, should add up K from C. So class, we're going to say, class, this I here can be written as one I. Do you agree? If I is standing on its own, class, in vector, it means one I. If J is standing on its own, it means one J. If K is standing on its own, it means one. Please take note. And if it was minus I, it means minus one I. If it was minus J, it means minus one. Minus K means minus one. So they don't need to put this one. If you see minus I, just know that it's minus one I. If you see minus J, it means it's minus one J. If it's minus K, it is minus one K. Please take notes. Class, why am I putting this one? Because when adding up vectors, we first of all add up the coefficients. So this 2 plus 1 is 3. 3 plus 3 is, you now say I. So the addition of these three i's is 6. How did I do it? Add up the coefficient 2. That's why I had to put 1 here because nothing here, right? I had to put 2 plus 1, 3, 3 plus 3, 6i. Now coming to this side, you have minus 3. Let's make it a minus 3 plus 2 plus 6. Minus 3 plus 2 plus 6. What is 2 plus 6? 8 minus 3. 8 minus, what is 8 minus 3? So the resolution of everything here is plus 5. Plus, and what's there? J, right? For plus 5j. So we have 6i plus 5j. Now let's resolve this side, the k side. You see that I resolve I to I, j to j, k to k. Let's resolve the k side. We have plus 4 minus 3 minus 4. Plus 4 minus 3 minus. Class, plus 4 and minus 4 cancel each other. When two numbers are existing and one is plus and one is minus, they cancel each other. Plus 5 minus 5 is 0. They cancel each other. Plus 6 minus 6 cancel each other. So if plus 4 has cancelled minus 4, what is left is just minus 3. And this is what? K, right? So our final answer for A plus B plus C is 6i plus 5j minus 3k. This is how you add up vectors. If it was subtraction, thank God we have subtraction in some of the questions, right? The same thing you also do this, but just the difference is that you'll not be subtracting instead of adding. You'll be subtracting instead of adding. I've noticed that since I started this online class, people are now lazy to come to class. The attendance has dropped because they feel that they will now watch it online. You know, before, when people don't have a second opinion, they will just come for class. But it doesn't mean, those people that are coming for physical class, well done, keep doing it. Because you're the one that first get the first-hand knowledge of the teaching step by step. This online class is only for those that absolutely cannot make it to physical class. They just cannot. So they have to settle for this because they can. But if you can make it to physical class, be around. Be around. I'm just trying to make this online class as the same thing with physical. So that it's the same thing because it's just different. Just that the person is not sitting down here. So I'm trying to make sure that they understand it too. But if nobody's coming for the physical class, then you also discourage me for recording. So everybody cannot say I'm not coming for physical class. It means I will not be teaching myself. So please tell your colleagues, be in class, especially Saturday. You don't have any excuse on Saturday. Saturdays are general class. Everybody should be around. Saturdays are general. Everybody should be around on Saturday. Be around. As much as possible, be coming for the physical class. Only when you cannot make it, you say, thank God there's a backup, right? There's an online class to back you up, but don't now replace it completely. This is like a plan B when you cannot attend. Not that you now replace it completely. So please try to be around. Tell your colleagues, let them be around. Be around in class. We have done A plus B plus C. Let's go to the next one. The next one says 2a minus 3c. So we must first go and find 2a. Class, the question gave us a. So what is 2a? 2a means multiply a all through by 2. 2a means multiply a all through by what? So a was 2i. 2i times 2. 4. A was minus 3j. Minus 3j times 2. Minus 3 times 2. Minus 6j. A was 4k. 2 times 4. 8k. So class, if a is this, 2a is twice of that, right? And they say minus 3c. Minus 3. The question said 2a minus 3c. 3c means multiply c all through by 3. So c was 3i. 3 times 3. 9i. C was 6j. 6 times 3. 18j. And C was minus 4k. Minus 4 times 3. Minus 12k. Minus 4 times 3 is minus. Now we have 2a and 3c, right? Let's now apply the question. 2a minus 3c. 2a minus 3c. Let's solve. 2a minus 3c. 2a minus 3c. So 2a minus 3c now becomes 4i minus 9. Remember, it's I to I, j to j, k to. Let's resolve. 4 minus 9 gives you minus 5. So we have minus 5i. We have resolved this. 4 minus 9 is minus 5i. Let's resolve this. Minus 6 minus plus 18. Minus 6 minus plus 18. Because it's plus 18 here. Minus 6 minus plus. What is minus times plus? It's minus. Minus 6 minus 18. Or minus times plus is minus. So minus 6 minus 18 gives you minus 24j. Minus 24j. Now let's go to the k side. Plus 8 minus 12. Plus 8 minus 12. Plus 8 minus 12. Minus times minus. Plus 8 means 8, right? Minus times minus. Plus. So 8 plus 12. 20. So this is plus 20k. And we have gotten 2a minus 3c. We have gotten 2a minus 3c. Where are you lost? 2a minus 3c. 4 minus 9 is minus 5. We did it now. 4 minus 9. Punch your calculator and check. Minus 6 minus plus 18. Minus times plus is minus. That's how you do it. Minus 6 minus plus. Anytime minus and plus or two similar signs meet each other, you multiply each other. So minus 6 minus plus 18. Minus times plus minus. That's minus 6 minus 18. Punch your calculator, you see there's minus 20. J, K to K. Remember I was doing I to I, right? J to K to, and I listed it out here. You check, you get your answer. You can go and reward the video if you are still lost. Now, let's go to the third question. The third question said we should find A plus 2B minus 4C. A plus 2B minus 4C. Who is A? A is 2I minus 3J plus 4K. Who is 2B? 2B means multiply B all through by 2. So if B is I, 2 times I, 2. If B is 2J, 2 times 2J plus 4J. If B is minus 3K, minus 3 times 2, minus 6. Just multiply by 2, that's all. It's too simple. Minus 4C. Who is C? 3I plus 6J minus 4K. Multiplied by 4. To get 4C, multiply C by. So let's start multiplying C by 4. 3 times 4, 12I. 3 times 6, 18J. 3 times minus 4. What's 3 times minus 4? 3 times 4, 12. But there's a minus. That's minus 12K. So this. 4. Sorry, 4. 4, sorry. 4 times 3, 12. 4 times 6, 20. It's her face I'm looking at. Her face is looking so confused. So I'm trying to make you understand. You look lost. So I'm trying to simplify it as simple as possible. What is 4 times 3? You didn't know that one too. Are you here? 4 times 3 is what? 12. Right? 4 times 6, 24. I can't teach us more simpler than this now. 4 times 3. Or how low should I go? This is university. 4 times minus 4. Minus 16K. I was looking at that. I forgot that it's even 4 I'm using. I started using 3. I'm trying to make you understand because you asked the question just now. So A plus 2B minus 4C. A plus 2B minus 4C. So this plus this minus this, that's what it means. Anytime this minus this plus this minus this plus this minus this. Class, I would advise that you get A plus 2B first. But let's do it together now. 2 plus 2. 4 minus 12. 4 minus 12 is minus 8i. Class, this thing you don't need to be using your head. You have calculator. 4 minus 12. So this place, you don't have any excuse to say you don't understand. When you have calculator, why must you use your head? 2 plus 2, 4. 4 minus 12 minus 8. So this is not about, I don't understand. This is about calculator. Press 2 plus 2, 4. 4 minus 12 minus 8. Minus 3 plus 4 is plus 1. Plus 1 minus 24. Plus 1 minus 24 is minus 23j. Look at it. Let me do slowly. 3 minus 3 plus 4, then minus plus 24. Because A plus 2B minus 4C. So A is minus 3, 2B is plus 4, minus plus 20. Minus times plus is what? Minus. So minus 3 plus 4 is plus 1 minus 24. Plus 1 minus 24 is minus 23. You don't need to think this. Just use your calculator. Minus 23j. Let's go to K now. K is plus 4 minus 6 minus 16. Plus 4 minus 6. In fact, let's do it the right way. Plus 4 plus minus 6 plus minus 6 minus 16 minus 16. Plus 4 plus minus 6 minus 16. This is plus 4 plus times minus 6 minus times minus plus 16 minus times minus plus. What is 4 plus 16? Is it not 20? Minus 6. 4 plus 16 is what? 20 minus 6 plus 14, right? So this plus 14k. This is A plus 2B minus 4C. A plus 2B minus 4C. Remember, if you're confused anyway, just use your calculator. Addition and subtraction, you don't need to be thinking it. Calculator is allowed in the exam. Just add up or subtract where necessary. Add up or subtract where necessary. Calculator is allowed. Calculator is, so add up or subtract where necessary. 4 plus 16 is what? 20. 20 minus 6 is what? 14. Now the last one. The last one now is 3b minus a plus c. 3b minus a plus c. 3b minus a plus c. Class, have we done anything that gave us 3b before? No. So let's go and find 3b. 3b means multiply b all through by 3. Class, this is b here. Multiplying this b all through by 3 will give us what? 3 times I. 3i. 3 times 2. 6j. 3 times minus 3. Minus 9k. Class, this is 3b. Minus a, right? Minus a. Thank God, we don't need to do anything to a. A is 2i minus 3j plus 4k plus c. Who is c? Who is c? 3I plus 6j minus 4k. Plus 3b minus a plus c. 3b minus a plus c. 3b minus a plus c. Let's find the answer. 3b minus a. 3 minus 2. That's 3 minus 2 plus 3. 3 minus 2 plus, because 3b. Take anybody from 3b, subtract minus a, then plus. So who is from 3b? 3 minus 2 plus 3. 3 minus 2 is 1 plus 3 is what? 4. So we have 4i. Let's go to the j part. Let's go to the j part. 6 minus minus 3 plus 6. 6 minus minus 3 plus 6. Look at the 6 minus minus plus minus times minus plus 6 plus 3 plus 6. 6 plus 3, 9 plus 6, 15. 9 plus 6, so we have plus 15j. That's the j part. That's the j part. Let's go to the k part. The k part is minus 9 minus plus 4 plus minus 4 plus minus times plus. So that's minus 9. Minus times plus is minus 4. Plus times minus is minus 4. In case you have issues in plus times minus and minus times plus, just to be sure that that's not what your problem is. Plus times plus is plus. Minus times minus is plus. Plus times minus is minus. Minus times plus is minus. Please take note. In case this is what is given, if this might be the reason why you are not understanding how we are multiplying and getting plus or minus, that will cover you. Class, as we said, minus times plus minus. Plus times minus minus. Minus 9 minus 4 minus 4. Use calculator in case you are not sure how to do it. Is minus 17. That will be minus 17k. So class, this is 3b minus a plus c. And with this, we've taken sufficient example on addition and subtraction of vectors. We have taken sufficient example on what? Addition and subtraction of vectors. Before we go to multiplication of vectors, I will quickly teach you magnitude of a vector. Magnitude of a vector. How to calculate the magnitude of a vector. So our next topic will be magnitude of a vector. Please, my video is still recording, right? Thank you. Magnitude of a vector. Right, and the magnitude of a vector is the size of the vector without direction. Magnitude of a vector is the size of the vector without direction. What's the size of the vector without what? Direction. Magnitude of a vector is the size of a vector without direction. Is the size of vector without direction. Without what? Magnitude of a vector is the size of a vector without direction. Class, if you are given a vector A equals to 3I plus 4j. Class, this symbol for magnitude is this symbol. You see, find these two symbols beside A is magnitude. It means they're asking you to find the magnitude of a vector. Class, to find the magnitude of a vector, start with the square root. Start with the square. Now take the I coefficient, which is 3, and square it. Plus take the j coefficient, which is 4, and do what? Class, do not take I and J when you're solving magnitude, because magnitude is the size of the vector without direction. I and J is showing the direction of the vector. I is showing the direction on the x-axis. J is showing the direction on the y. We don't need direction in magnitude. So just take the numbers, this size, 3 and 4. So start with a square root. Take this 3, square it, plus take this 4, do what? Square it. And you have gotten the magnitude of the vector. This will be square root. 3 square is 9. 4 square is 16. 9 plus 16 is 20. And the square root of 25 is 5. And the square root of 25 is 5. So the magnitude of a vector is the size of vector without reference to what? Without direction. Another name for magnitude is modulus. If you don't want to ask me, they say find the modulus of the vector class. They mean the same thing, modulus. Another name for magnitude is what? Modulus. Modulus of a vector. Another name for magnitude is modulus. Let's see that. Class, I just gave you a two-dimensional vector. What if the vector is three-dimensional? You have to find magnitude. What will you do? What if the vector is three-dimensional? You have to find magnitude. What will you do? Let's look at the vector A equals to 2i minus 3j plus 4k. This is a three-dimensional vector. And you have to find the magnitude. Class, no problem. Still apply the same rule. Start with the square root. Take this 2 only. Don't take the I. Take only the 2 and square it. Plus, take this minus 3. Like, don't just take 3, or take the sign with it. Plus minus 3 and do what? Square it, and plus 4 and do what? This is how you find the magnitude. So the square root. What's 2 square? 4. 2 square is what? 4. Plus minus 3 square means minus 3 times minus 3. And minus times minus is plus. 3 times 3 is 9. So minus 3 square will eventually give you a positive 9. Minus 3 square will give you a positive 9. And 4 square will give you what? 16. So you're going to have square root. 4 plus 9 is 13. 13 plus 16 is 29. So root 29 will now give you, find the square root of 29 with calculator. Find the square root of 29. You now have your final magnitude of this vector. You will now have the final magnitude of this vector. Class, now that we have looked at magnitude of vector, next thing we'll look at is unit of a vector, yes? You see? Magnitude, yes. Yeah, exactly, yes. Class, unit vector. The unit of a vector is the vector itself divided by the magnitude of the vector. The unit of a vector is the vector itself divided by the what? Magnitude of the vector. The unit of a vector is a vector divided by the magnitude of the vector. Units of vector is the vector divided by the what? Magnitude. Class, the unit of a vector A, look at the symbol for units. If you see the symbol, it means they're asking to find the unit of a vector. Is A divided by magnitude of A. The unit of a vector is the vector itself divided by the magnitude of the vector. The unit of a vector is the vector itself divided by the magnitude of the. So if you have a vector A equals to 3i plus 4j, and you ask to find the unit of the vector A, unit of vector A will be 3i plus 4j. Class, we have done the magnitude of this vector before, right? Divided by magnitude of the vector, which is 5. Remember when we did it? We have done the magnitude of 3i and 4j, and we got 5. Remember? Let me remind you when we did this. The magnitude of the vector A is take this 3, square it, and take this 4, do what? Square it. 3 square gives you 9, 4 square gives you 16, and 9 plus 16 gives you 25, and square root of 25 gives you 5. And So we have 3i. The unit of the vector is 3i plus 4j all over 5. 3i plus 4j all over 5. So 9 plus 16 gives you 25. And square root of 25 is what? 5. So that's how we got the magnitude of A as 5. Because the unit of a vector is the vector itself. This is the vector itself. Divided by the magnitude. Magnitude is 5. Which can still be simplified as 3i over 5 plus 4j over. Because this 5 belongs to both 3i and 4. And 3 divided by 5 is 0.6 I. 4 divided by 5 is 0.8 J. 3 divided by 5 is 0.6. 4 divided by 5 is 0.8. Class, that's the unit of a vector for you. That's the unit of a vector for. It's now time to go to I want to teach you rectangular and polar form of a vector. Rectangular and polar form of a vector. Rectangular and polar form of a vector. Please be fast. Okay, class. Vectors, two-dimensional vectors. Well, this is for two-dimensional vectors. Write down. Rectangular and polar form of a two-dimensional vector. This part I want to teach you is for only two-dimensional vector. It cannot be applied to three-dimension. It can only be applied to two-dimension what? Vector. Rectangular and polar form of two-dimension vector. Rectangular and polar form of two-dimension vector. Note, two-dimension vectors can be represented in two forms. Two-dimension vectors can be represented in two forms. One is rectangular form. Two is polar form. One is rectangular form. Two is polar form. I said note, two-dimension vectors can be represented in two forms. One is rectangular form. Two is polar form. Class, one of these methods you already know it because that's what we have been using so far. Class, in the rectangular form, the I and J components are spelled out outrightly. In the rectangular form, continue writing. In the rectangular form, the I and J components, in the rectangular form, in the rectangular form, the I and J component are spelled out outrightly. outrightly. But in the polar form, the magnitude of the vector and angle subtended by the vector is spelled out. So to express a vector in polar form, we need the magnitude of the vector and the angle subtended by the what? Vector. We need the magnitude of the vector and the angle subtended by the what? By the vector. So class, sometimes we might need to represent a vector from rectangular to polar. We must convert a vector from rectangular to what? Polar. If you have a vector A equals 3i plus 4j. Class, this vector is in rectangular form. Let me show you why. It's rectangular form. 3i means the x-axis, remember. So 3i. 4j means the y-axis. 4j, this is y-axis. This is x and this is y. Say A is 3i plus 4j, right? Class, if we draw a line parallel to this y-axis on this side, and draw a line parallel to this x-axis on this side, we're going to have a rectangle. We're going to have a what? So this is 3i, and this is 4. So anytime you see a vector represented like this, it actually means rectangular form. It means rectangular form. When you want to put it, I'll pause it first. So calm down. Set it outside first. Okay, so you will need to put the leg inside there. Raise it up first. Now, A is 3i plus 4j is in rectangular. How do you change this vector to polar? You need the angle subtended by the vector and the magnitude of this vector. I intentionally use this vector because we have gotten the magnitude of this vector before, right? When we say square root, remember? 3 square plus 3 square is what? 9. 4 square is 9 plus 16 is 20. And square root of 25 is. So I've gotten the angle, class. We need the angle. So I've gotten the magnitude. We've gotten the magnitude. Now we need the angle subtended by the vector. Class, the angle subtended by the vector is given by the formula tan theta equals to y all over x. Class, the y component is the j-axis, the x component is the y. So y is 4, x is 3. So the angle subtended by tan theta is 4 all over 3. And tan theta, 4 divided by 3 is 1.333. 4 divided by 3 is 1.33. Making theta squared to the formula, tan will move out to this side and become tan inverse, tan raised to power minus 1 of 1.333. Tan raised to power minus 1 of 1.333 will give you what? Tan raised to power minus 1 of 1.33. So once you do it first, shift tan. In your calculator, you press shift tan. If you're using calculator, press shift tan 1.333. Please be fast. 53.12 degree. Class, the angle subtended by this vector is 53.12 degree, and the magnitude of this vector is 5. So class, this vector in polar form is the magnitude of A and the angle of subtended by A. The polar form of the vector is written in this format. The magnitude of the vector and the angle subtended by the. So what is the magnitude of the vector, class? Magnitude is 5. And what's the angle subtended by the vector? 53.12 degree. This is the polar form of this vector. So this vector 3i plus 4j is in rectangular form, has now been converted to polar form. This is rectangular. When you see I and j, know they are in rectangular. When you no longer see I and J, but you see magnitude and the angle, know that is what? Polar. This is polar, this is rectangular. Okay? Right, welcome back. We've just looked at rectangular and polar representation of what? Of vectors. Now, class, the interesting thing about this is that I've just taught you how to convert from rectangular to polar. I can still return the polar vector back to rectangular. Class, if this vector of A equals to 5 angle 53.12 degree, this is polar, right? What if I'm asked to return it back to rectangular form? Will I still get back? What was the rectangular answer I got then? A is what? What was the rectangular form before you returned it here? 3i, right? Plus 4j, right? This was rectangular form. Then we converted it to polar. How did we convert to polar? Let me remind you one more time. We found the magnitude of the and the angle sustained by the vector. The magnitude of the vector and the angle sustained by the what? Now, class, I want to teach us how to change polar to rectangular. What we have learned is change rectangular to polar, right? Let's teach us how to change polar back to what? And if we are correct, we should get back 3i plus 4j. Class, we change this vector polar to rectangular. We are going to say A is going to be equal to 5 cos. You start with cosine. What's the angle? 53.12 degree. Put everything inside the bracket. I plus 5 again. But this man, instead of cos, you say sine. You say what? Sine 53.12 degree. Put everything inside bracket. This is what? J. Class, in the rectangular form, we introduce back I and J. Remember that in the rectangular form, I and J must be spelled out. But in the polar form, we don't need I and J. You take the magnitude 5 and the angle. But what will be between them? If it's I, is cos. Then you take 5 again. But for this time, you now put what? Sine, then J. So one is carrying cos, the other one is carrying sine. Class, we're now going to resolve 5. Someone should help me. What is cosine of 53.12 degree? Punch calculator. What's cos 53.12 degree? 0.6 into bracket 0.6 I plus 5. Please, what is sine of 53.12? What is sine of 53.12? 0.799, which is approximately 0.8. J. 5 times 0.6 is clearly 3, right? 3i plus 5 times 0.8 is 4j. 3i plus 4j. This is how we land at 3i plus what? 4j. You see, we have successfully converted this polar vector back to rectangular. So we have gone both ways. We have gone from rectangular to polar. We have gone from polar back to rectangular, class. Class, it's now time to look at multiplication of vectors. It's now time to look at what? Multiplication of. That is where we have the scalar and dot product of vectors. Multiplication of vectors. Class, there are two methods to multiply vectors. There are two methods to multiply what? We have what we call the scalar product. And we have what we call the vector product. Class, this same thing we are doing for physics this week. Next week will be for another course like that till we finish it. The other week will be for another course like that till we finish. So that's the idea. That's the what? Idea of the class. So next week, I'll take maths. I'll take what? Maths. Since we'll be doing chemistry on weekends on Saturday, next week I'll take maths, chapter 1, chapter 2, like that. I'll take maths. I want to be done with one of your maths by next week. I want to be done with one of your maths by next week. Scalar product, we have scalar products. And we have vector products. Class, there are two ways of multiplying vectors. We have scalar and what? Vector. The scalar product is also called the dot product. Dot product. Why the vector product is also called the cross product. So class, the scalar product you see, how do you know you are aspiring the scalar product? You see this dot. And vector product, you see this cross. So they have their signs, they have their what? And they have their different rules, class. Class, two same vectors, if you multiply them with scalar product and multiply them with vector product, you have different answers. You have different, two vectors. You multiply them with scalar, you have one answer. Vector, you have another. So imagine saying that there are two ways of multiplying something. Imagine, let's say we have 2 times 3 is 6, right? Imagine saying that there are two ways of having 2 times 3. One will give you 6, one will give you another answer. That's what we're talking about in vectors. Interesting, right? Now, class, the rules. Let's start with scalar product, the rules. Class, scalar means no direction. So, oftentimes than not, our final answer for scalar product will not contain direction. And what represents direction? I, J, K. Our final answer will not carry I, J, K. Scalar product. But in vector product, after finishing the vector product, the final answer will still contain I, J, K because it's vector product. Vector means direction. Scalar means without direction. Let's start with vector product, the rules, class. Class, the rules for vector products. Did I say vector? Scalar product, the rules for scalar product, class. Class, when multiplying scalar product, similar vectors, the multiplication of similar vectors, who are similar vectors, I to I, J to J, K to K is 1. Is what? Class, I dot I, 1. J dot J, 1. K dot K, 1. When the vectors are the same, their dot product is 1. When the vectors are the same, their dot product is 1. When the vectors are the same, their dot product is 1. When the vectors are different, I to J is 0. J to K, 0. K to I, 0. When the vectors are the same, the answer is 1. When the vectors are different, the answer is 0. Simple. That is simple and short of scalar product. We now need to apply. We need to do what? Apply. We need to apply. Class. Given the vector A equals 2I plus 3J plus 4K and B equals I plus 2J minus 3K. Given the vector A equals 2I plus 3J plus 4K and B equals I plus 2J. Remember that I is 1I, right? I plus 2J minus 3K. Class, we have to find A dot B. A dot class. Remember, we gave you the rules for dot product, also called scalar product. Class, scalar product rules tells us that only similar vectors will give you a reasonable answer. When you multiply different vectors, the answer is what? 0. So when I want to multiply these two vectors, I will take I to I will take J to J, I will take K to class. I does not need to go to J, I does not need to go to K because the final answer is nothing, 0. Anytime I meets J, 0. Anytime I meets K, 0. Only I to I can give a reasonable answer. Only J to J can give a reasonable answer. Only K to K can give a reasonable. So class, I will go to I, J will go to J, K will go to 2 times 1, 2. I dot I, 1. Remember that I dot I is what? So when multiplying vectors, first multiply the numbers, then multiply the vectors. 2 times 1, 2. Check your book. I to I is what? 1. Check the rule I just gave you. Next one, 3 times 2, 6. j to j, 1. The next one, plus 4 times minus 3, minus 12. Who is saying 1? Plus 4 times minus 3, minus 12. Plus 4 times minus 3. First of all, plus times minus, minus. Thank God I gave you the rule, right? Plus times minus, minus. 4 times 3, 12. K dot K, 1. So that 2 times 1 is 2. Plus 6 times 1 is 6. Minus 12 times 1 is minus 2 plus 6, 8 minus. What's 8 minus 12? Minus 4. So class, imagine these two big vectors. The final answer for their dot product is just minus 4. These two big vectors, the final answer for their dot product is minus 4. And you are done. Are you seeing it? Class, remember that example is usually very simple. Classwork. Get ready for your classwork. Class, I'd like to introduce a third vector C into this component. I'll still give you from this question A, B, and C. A, B, and what? Let's assume that C now equals 3I plus 6J minus 4K. Class, your question, your classwork is to find A plus B dot C. If you are watching online, pause this video and do this classwork. I assume you're having a writing material. You're not watching a skit or comedy skit. You're watching a class. This is physics. That's calculations. So anytime you're watching our videos, you should have a writing material, your pen and your book. Pause this video, attend this classwork to see your progress, so that you're making progress with the class. Find A plus B dot C. All right, you've had enough time to do the classwork. Welcome back. B equals I, right? Plus 2J minus 3 cancel. Class, they say find A plus B first, then dot C. That means the answer between A plus B that you now use to dot C. You now use to dot. So this is a combination of addition and what? Multi. Add this 2I, this 1I, 2 plus 1. I want to find A plus B first now. Class, the question said A plus B first, then dot 2 plus 1, 3. 3 plus 2, 5J. Plus 4 minus 3, plus 1K. 4 minus 3 is plus. Class, this A plus B. Now dot C. Who is C? 3I plus 6J minus 4K. 3I plus 6J minus 4K. This is C, right? So A plus B dot C means find the dot product between these two. Class, when you're doing dot product, it's not I to I. 3 times 3, 9. I dot I. 5 times 6, 30. J dot J. Plus 1 times minus 4. Minus 4. K dot K. 9 times 1 is what? 9. 30 times 1 plus 30. Minus 4 times 1 minus 9 plus 30 minus 4. 9 plus 30 minus 4. What is 9 plus 30? 39. 39 minus 4. 35. A plus B dot C. Who got it? Online students, you get to raise up your hand if you got it. They're laughing. So if you got it, your final answer should be 35. This is dot product. Now let's go to cross product or vector product. Let's go to cross or vector product. If you didn't get it, remember that there's a video to go and watch again. Watch again till you get it. Like I said, coming to class, if you can come, it's still very, very good. Physical class, very, very good. Very, very good. Be around. Please, those of you watching online, be around in the physical class. Stop missing classes because I've started posting it online. It's bad. Stop missing class. If you are free, be around. Be around. As you can see, every day I've been coming to class, I've been teaching. Any day you miss class, there's no day I've missed my class. Except the day we say we are not having class. Class, we need to go to vector product. We need to go to vector. We have just looked at cross product. Let's now look at, we have just looked at dot product. Let's now look at cross. Underneath for vector product is cross, right? It's cross product. vector product or cross. Class, let's see the same examples. A equals 2I minus 3J plus 4K. And B equals I plus 2J minus 3K. Now we have to find A cross B. A cross. Class, I must give you the rules. When we did dot product, did I give you the rules? Let's look at the rules for cross product. Class, we have I, we have J, and we have K. We have I, we have J, and we have K. Class, for cross product, I cross J equals K. When you multiply two vectors, the answer is the third vector. So if you say J cross K, what's the third vector that is not mentioned? I. And K cross I, who is third vector not mentioned? J. Very simple. I cross J is K. J cross K is I. K cross I is J. Class, the reverse. That's where the problem starts. If I to J is K, class, J to I, if J starts first, let's reverse. Let's just tweak this, reverse this. This I to J is K, right? But J to I is minus K. Is minus what? K. Please take note. If J to K is I, K to J is minus I. If K to I is J, I to K is minus J. Please take notes. Please take notes. Take a moment and observe carefully. Please take notes. I to J is K. I to J is K. J to K is I. K to I is J. But once you reverse it, the opposite is the case. Once you reverse it, the opposite is the case. Applying this rule here, applying this rule what? A cross B. Class, don't forget it's 1 here. I means 1I. I means 1. We're going to say 2. Remember, multiply the numbers first before the vectors. Oh, good, interesting. I just remember something. But this is not vector product. This is not scalar product. This is vector. This is vector product. So class, in vector product, remember that when we're doing scalar products, similar vectors to each other, right? But class, for vector product, is different vectors to each. If I goes to I forgot the one part of the rule again is that I cross I is 0, class. For vector product, similar vectors gives you K cross K. Class, when the vectors are the same, the answer is 0. For cross product or vector product, when the vectors are the same, the answer is what? So class, but in scalar product, go back to scalar product. When the vectors are the same, the answer is 1, right? It's when they are different that it is 0, right? Class, for vector product, it is when they are different that it makes sense. But when they are the same, it doesn't make sense. It's 0 is what? So for vector product, similar vectors will avoid each other. For vector or cross product, similar vectors will what? Avoid each. Why? Because if you multiply 2 times 1, 2, but I to I is 0. So 2 times 0 is, watch now, 2 times 1, 2. I cross I, look at it, is what? 2 times 0, 0. We just wasted our, so class, similar vectors don't go to each other. Instead, for cross product, different vectors go to each other. So these two, remember that it's who is crossing who, you must ask yourself. A is, they should find A cross B. A cross, let's assume we are looking for A cross B, means that A is crossing over to B. So the members of A must cross over to members of B, cross product. But I cannot cross to I. The first member of A is 2I, and he wants to cross, because 2I will first cross to B, then 3J will also cross to, then 4K will cross to what? B. So let 2I first cross to B. It will first come to this first person, say, no, we are the same, it's 0. It will pass, go to this person. Yes, we are not the same, we can walk. 2 times 2. Now, I cross J, what's the table there? I cross J. I cross J is K. I cross J is Follow carefully, please. 2 times minus 3, minus 6. I cross k, check the rule there. I cross k is minus j. I cross k is minus j. Notice I multiply the numbers first before the what? Vectors. I first said 2 times 2, 4. I cross j, k. I said 2 times minus 3, minus 6. I cross k minus j. Class, I has finished crossing because has crossed j and it has also crossed. Remember that A cross B. So A is crossing B. Means that every member of A must cross members of what? B. So I has crossed J and has crossed K. We know why he did not cross his fellow I. He will give us 0. Now move over to J. J must cross I and K. He will not cross his fellow J. Because J to J is 0. So J will cross I and K. Let J cross I now. First of all, multiply the numbers before the vectors. Minus 3 times 1. Minus 3. J cross I minus K. Check the rules. J cross I minus K. Are you saying? Now, minus 3 times minus 3, positive 9. Because minus times minus is plus. 3 times 3 is 9. J to K is I. Is what? Class, J is done crossing. J is done. Is now remaining K to cross. It's remaining what? It's remaining K to cross, yes? We'll do the metrics, but I'm teaching, I'm recording. So I should leave what I'm doing and go to metrics. I'm following a pattern. You should have known that I will come to metrics. Don't just pause me for flimsy reasons, please. After this, won't I teach metrics? I'm trying to save people's data too, because the longer this video is, the more data they are going to exhaust. Which is better. As I say, come to physical class. If you can come to physical class. I still teach every day in Uniport. Every day I teach. Ask for a timetable, message me, and come to the physical class. Only the online class should be your backup. Maybe that day you have practicals, or you want to go and do one clearance. You come, okay, say, okay, thank God they are recording the class. I will watch that one online. So please, if possible, try to come to physical class. Those that should be fully online students are those that are working. Maybe you are working part-time. That's what you are the one I did this class for. You're working part-time, you're busy, or you stay very, very far. You don't have a place around school, so you are coming from far. So even if after class, you usually rush home, then this class is for you. Then you have to settle for the online class. But if you have a chance, you are staying around school, Alakaya, Alu, Choba, or you stay in the hostel, come for the physical class. Come for the physical class. Try your best. Then days you cannot meet up, we'll back you up with online since you have registered with us. If you have not registered with us yet, register with us so that you can attend this class. Now, K, 4 times 1, 4. K to I is J. K to I is what? J. 4 times 2 is 8. K to J is minus I. K to J is minus. Class, the crossing is over now. It's to resolve. 4 times K. 4K. Minus times minus is plus. 6 times J is 6J. Minus times minus is plus. 3 times K, 3. 9I. 9 times I is 9I. 4 times J is 4J. Plus times minus is minus. Minus 8I. Minus 8I. Class, let's now collect like 10. Let's start with the I's. We have 9I here, right? So A cross B is 9I minus 8I. Let's collect the J's. Where are the J's? Plus 6J plus 4J, right? Plus 6J plus 4J. Let's collect the K's. Plus 4K plus 3. Plus 4K plus 3K. 9I minus 8I is I. 6J plus 4J is 10J. 4K plus 3K is 7K. Class, this is A cross I plus 10J plus 7K. This is A cross B. This is A cross B. I will now teach you the matrix method. There's a matrix method of solving this, which I'll teach you. But usually, if you are teaching cross product, you must first see this normal method. So the next one we'll look at now is matrix method of solving cross products. Class, I'll solve this same vector using matrix determinants. I'll solve this same vector using matrix determinants. And you see that we're going to have the same answer. This we are writing right fast. Please write fast. Pity people studying online. I stand now, we're just wasting time. This same vector, but now matrix. Class, in the matrix method, you first letter your matrix I minus j and k is a rule, class. I follow this exact rule. Something that is a rule is a rule. I minus j and k. Letter your matrix I minus j and k. Now represent your A and your B. Class, for A, who is I for A? 2. Right? Who is I for B? Who is J for A? Minus 3. That is the number for minus 3. And who is K for A? 4. I'll come again. Who is I for A? 2. Who is J for A? Minus. Who is J for K? Who is K for A? Plus what? 4. Plus 4 is same thing as 4, right? Let's go to B. Who is I for B? 1. Who is J for B? Who is K for B? Minus 3. We have transmitted our vector question into the matrix. We don't need this again now. Matrix will take care of the rest. The matrix will take care of the... We're now going to say, after doing this, we're going to form separate matrix for the I components. Form a separate matrix for the J components. And the one that J is carrying minus, don't forget. If I let me put it there, this the I matrix, the minus J matrix, and the K. Class, when you're forming the matrix for the I component, do not mention the members of I. Only mention these members of J and K. Because I to I will give you 0. So it's going to be minus 3, 4. Minus 3 what? 4, 2, and minus. This is what will make up the I matrix. When forming the J matrix, do not mention the members of J. Mention I and K. That's 2 and 4. That's 2 and what? And 1 and minus. And when doing for K, you know the obvious thing to do, right? Don't mention K. Mention I and J. So that's 2 and minus 3. 1 and plus. You have formed the matrix for I, J, and K. You're almost done. You're almost. We'll now resolve the I component, get an answer. Resolve the J component, get an answer. Resolve the K component, get an. Don't forget, this is the same question we solved with the normal method. So I'm using this exact same question. So you can see that the two approach will give you the same answer. The two approach will still give you the same answer. Class, when solving matrix, you have the A position, the B position, the C, and the D position. Class, when you want to resolve this matrix, you're going to multiply A to D and B to C. So that the resolution of this matrix is AD minus BC. Class, to resolve this matrix, it is A times D, which is AD, minus B times C, which is B. So if you transfer this matrix to this, who is in position A in this matrix? Minus 3. Minus, when any number here is in position A. Who is in position B? 4. Who is in position C? 2. And who is in position D? Minus 3. Who is in position A here? 2. B. C. D. Who is in position A here? B. C. D. Class, to resolve this matrix, take position A and multiply by position D. Are you seeing A, D? So minus 3 times minus 3, minus 9. Then subtract from the multiplication of this times this, 4 times 2. Everything, which matches this I? This is what? Minus 9 minus 8. Sorry, minus 3 times minus 3 is 9. Minus 3 times minus 3 is positive 9. minus 4 times 2, 8. So 9 minus 8, 1 I. 1 what? They have resolved the I component. Let's resolve the J component now. Take A multiplied by D. Remember, 2 times minus 3, minus 6. 4 minus, you say minus, 4 times 1, everything into bracket, minus J. Remember that J is minus. Minus 4 minus 6, minus 10 into bracket, minus J. Minus times minus, plus 10J, plus 10. Let's come again. 2 times minus 3, minus 6, minus 4 times 1, 4. Minus 6 minus 4 is minus 10. Times minus J is plus 10. Because minus times minus is plus. Coming to K class. 2 times 2, 4. Minus 3 times 1 is minus 3. Everything into bracket K. Minus times minus, plus. 4 plus 3 into bracket. 4 plus 3, 7K. So we have 1I plus 10J plus 7K. Is that what we got in the former question? 1I plus 10J plus 7 is A cross B. Claire, which one do you prefer? The first one or the second one? Second one? Okay, good. Anyone you prefer, you are good to go. I will advise you to take your past exam question and take more questions. If you are watching this class, try and get this past question. Your textbook will not be enough. Study your past exam questions. Study your past exam questions. After learning a tough topic like this, most students are having issues with vectors. Take your past exam question and solve. Go and look for tough questions on this topic and solve. This past question contains all your courses combined with solutions, step-by-step solutions. Take the past question. If you don't have this past exam question, you are not ready for exam. This past question will help you to know the lecturer's mind for the exam and you prepare yourself accordingly. Prepare yourself accordingly. Class, the last thing we look at under vectors, write down parallel and perpendicular vectors. Parallel and what? Okay, not that. Before we go to the angle between two vectors. Please, angle between two vectors. Write down angle between two vectors. Angle between two vectors. Class, this one will not take time. It's just a formula I will give you. Let's use these two vectors A and B again. Our vector A is 2I minus 3J plus 4K. 2I minus 3J plus 4. And our vector B is I plus 2J minus 3K. I plus 2J minus 3K. Class, you can be asked to find the angle between these two vectors. Find the angle between these two. Is cos theta equals to A dot B all over magnitude of A times magnitude of B. Class, this is the formula that will help you to find the angle between two vectors. Cos theta AB. Cos theta what? AB equals to A dot B all over magnitude of A times magnitude of B. A dot B all over magnitude of A times magnitude of B. Class, since I've given you this formula, you can easily get the angle. Because everything in that formula you know already. You know. Class, have we done A dot B for this question before? Have we found the dot product of these two vectors before? Check your notes. What do we have? I've used this example so many times. What's A dot B? Minus 4. Yes, we have done A dot B. We got minus. Please. Was it 2I plus 3J? Are you sure? 2I plus 3J, no problem. Are you sure? 100%? So A dot B is minus 4. All over. What is magnitude of A? I've taught you how to find magnitude of a vector, right? Let's really do magnitude of A here. Magnitude of A, start with a square. Take this 2, square it. Plus take this 3, do what? Square it. Plus take this 4, do what? What's magnitude of B? Same thing, start with a square root. Take this 1, square it. Plus take this 2, square it. Plus take this minus 3, square it. Class, the magnitude of A therefore will be square root. 2 square is 4, right? 3 square is 9. 4 square is 16. What square root? 4 plus 9 is 13. 13 plus 10 is 29, right? So the magnitude of A is root 29. And magnitude of B is square root. 1 square is 1 plus 2 square is 4. Minus 3 square is positive 9 because minus 3 and minus 3 is 9, right? 1 plus 4 is 5 plus 9 is root 14 root. So cos theta AB is minus 4. A dot B is minus 4. We have done this same example before, right? A dot B is minus 4 all over magnitude of A. Thank God, even if you don't know it, even if I've not done it before, if you have been following this class to this point, you can get A dot B by yourself, right? You know how to find dot product between two vectors, right? Now, minus 4. Now, magnitude of A, let's call it root 29. And magnitude of B is root 14. Someone should do the math for us. Cos theta AB, that's the angle between A and B, is minus 4 all over. Who has done the math for us on that? Root 29 times root 14 is what? Square root of 29 times square root of 14. Everything together will give you what? Huh? 9 what? 9.04. 9.04. Class, is this correct? Square root of 29 times square root of 14. What's square root of 29 times square root of 14? Class, please help us. Eh? What's taking so much time? Square root of 29. What's square root of 29 now, class? Eh? Square root of 29. 5 point what? And square root of 14. 3.741. Now, 5.385 times 3.741. 20.145. So minus 4 divided by 20.145. Minus 4 divided by 20.145. Class, minus 4 divided by 20.145. Eh? Minus 0.19. Now, we now make theta set of formula. Theta AB is, when cos comes to this side, what happens? It becomes cos inverse of minus 0.198. So shift, you press shift. How do you press cos inverse? Shift cos minus 0.198. Shift cos minus 0.198. You see? 101.420 degree. 101.42 degree is the angle between these two vectors. 101.42 degree is the angle between these two vectors. Class, with this, you see that that's how you find angle between two vectors. Class, there's another formula you can use to find angle between two vectors. If you don't want to use dot product, you can use cross product. Like if you're using cross product, we are going to say sine theta AB will be equal to magnitude of A cross B all over magnitude of A times magnitude of B. This is another formula for angle between two vectors, but this one uses cross product instead of dot. When it was dot product, you have cos, right? Cos theta AB equals to A dot B, right? All over magnitude of A times magnitude of B. But this one says sine theta AB equals to magnitude of A cross B. That means you first find A cross B, then you find the magnitude all over magnitude of A times magnitude of B. Class, let's take this question. Let's take this question. If P equals 7I minus 3J plus 2K and Q equals 4I plus 5J minus 3K. If P equals 7I minus 3J plus 2K and Q equals 4I plus 5J minus 3K, find the cosine angle between P and Q. So class, you see that they say find the cosine angle, means you cannot use this sine angle. So we have sine angle and what? Cosine. So if the question says find the cosine angle between two vectors, it's different from when they say find the sine angle between two vectors. Class, question 1, find the cosine angle. 2, find the sine angle between P and Q. So find the cosine angle, also find the sine angle. Find the cosine angle, also find the what? Sine angle. Before you solve this, quickly write down perpendicular and parallel vectors. This is the last thing, so we know we are done at once. Perpendicular and what? Parallel vectors. Perpendicular and what? Parallel vectors. For perpendicular, write down two vectors are set with perpendicular. Two vectors are set with perpendicular if their dot product equals 0. Two vectors are set with perpendicular if their dot product equals 0. Two vectors are set with perpendicular if their dot product equals 0. And if the angle between them is 90 degrees. Two vectors are set with perpendicular if their dot product equals 0. And if the angle between them is 90 degrees. Two vectors are set with perpendicular if their dot product equals 0. And if the angle between them is 90 degrees. Why two vectors are set with parallel if their cross product equals 0. Why two vectors are set with parallel? Why two vectors are set with parallel if their cross product equals 0. Two vectors are set with parallel if their cross product equals 0. Class, in the exam you could be asked, determine if the two vectors, which of the following two vectors are perpendicular to each other? Or which of the following two vectors are parallel to each? Perpendicular vectors are vectors whose what? Dot product equals 0. Perpendicular vectors are vectors whose dot product equals 0. While parallel vectors are vectors whose cross product equals. So just find their dot product. If it's 0, know that it's cross. If dot product is 0, who is perpendicular? Who is it, perpendicular or parallel? Dot product equals 0 is perpendicular. But if cross product equals 0 is what? Parallel. Is what? Parallel. Good. Class, given the vector D equals minus 5I, given the vector D equals minus 5I plus 6J minus 3K, and E equals 48I minus J minus 82K. Determine if the two vectors are perpendicular or not. Determine if the two vectors are perpendicular or not. They give you two vectors and say determine if these two vectors are perpendicular or not. Determine if these two vectors are perpendicular or. What will you do when you hear a question like this? If they say determine the vector perpendicular or not, what will you do? Find the dot product. Find the dot product. If it gives you 0, then they are perpendicular. If it doesn't give you 0, then they are not perpendicular. So your final answer is either yes or no. Yes, they are perpendicular. No, they are not perpendicular. What must be your answer for you to say yes? If you do dot product and you have 0, you say Yes, they are perpendicular. But if you do the dot product and you don't have 0, you have any other answer apart from 0? No, they are not perpendicular. Class, who has done the dot product? Remember that when you're doing dot product, I to I, J to J, K to K, right? Dot product is simple. Just I to I, J to J, K to... Minus 5 times 48 is minus 240. I to I is 1. Don't forget, it's dot product. I to I is... Class, minus J here means minus 1J, right? So plus 6 times minus 1 is minus 6. J to J, 1. Minus 3 times minus 32 is plus. Minus times minus is plus. 3 times 82. Someone should help me. 3 times 82. 3 times 82. 246. K to K, 1. K to K is what? Now minus 240 times 1 is minus 240. Let's write it up here. Minus 240 times 1 is minus 2. Minus 6 times 1 is minus 6. Plus 246 times 1 is plus 246. Now class, minus 240 minus 6 is minus 24 plus 24. Class, minus 246 cancels 2 plus 246 giving you nothing is remaining. So class, is this vector perpendicular or not? They are perpendicular to each other. Perpendicular to each other. Another example of two perpendicular vectors. Given the vector A equals 7I plus 8J plus 4K, and B equals 48I minus J minus 82K. Class, if you do these two vectors, they are perpendicular to each other because they are dot product to give you 0. This is a class of online viewers. This is a class for do it. You find out that you have 0. They are perpendicular to each other. So the same thing, if it's parallel, just do the cross product. If it gives you 0, they are parallel. If it doesn't give you 0, they are not. So why perpendicular? We use dot product to find out, right? Parallel, we use cross product to find out. Now, let's end the class vector with this. And I know I'm done with chapter 3 vectors. I already gave a class work, right? Perpendicular. This is also perpendicular. Parallel is just opposite. Just do cross product. If they give you 0, then it's parallel. If it doesn't give you 0, it's not parallel. But class, I'm asking you to determine if this vector is perpendicular to each other or not. These two vectors. I think who has gotten 0 already? You will get 0. You get... Class, I want to end this vector class with this question on the board. Cosine angle between P and Q and sine angle between P and Q. We have two ways of determining angle between two vectors. Cosine angle and sine angle. Cosine angle and sine. Class, the formula for cosine angle, first of all, cos theta PQ. Now it's PQ, not AB, right? Is P dot Q, because if it was A and B, it would be A dot B, right? But now this P dot Q, all over magnitude of P times magnitude of Q. P dot Q means find the dot product between P and Q, right? P dot Q means find the dot product between P and Q. Find the dot product between P and Q. P dot Q means find the dot product between P and Q. Class, dot product simply means I to I, J to J, K to K. 7 times 4, 28. I dot I, 1. Minus 3 times plus 5, minus 15. J to J. Plus 2 times minus 3, minus 6. K to K. 28 times 1 is 28. Minus 15 times 1 is minus 15. Minus 6 times 1 is minus 6. 28 minus 15 minus 15 minus 6 is minus 21. Minus what? Minus 15 minus 6 is minus 21. 28 minus 21 is plus 7. So class, the dot product between P and Q is 7. Is what? All over. Now we need to find the magnitude of P and the magnitude of Q. We need to go and find the magnitude of P and the magnitude of Q. Magnitude of P and magnitude of Q. Class, thank God we have taught you how to find magnitude of between two vectors, right? Class, magnitude of P, I've taught you, is to start with a square and take this 7, do what? So the magnitude, almost everything in vectors, you need to find magnitude. Minus 3, square it, and take plus 2, do what? 7 square is what? 49, because 7 times 7 is 49. Minus 3 times minus 3 is 9. 2 square is 4. 49 plus 9 is 58 plus 4 is 62. Root 60. So magnitude of P is root 62. Magnitude of Q. Let's go and find magnitude of Q. Let's find magnitude of Q on this side. The magnitude of Q will be square roots. Take 4, square it. Take 5, square it. Take minus 3, do what? So you have root 4 square is 16. 5 square is 25. Minus 3 square is 9. 16 plus 24 plus 9 is 25. 50, root 50. Everything is root. So we have root 62 times root 50, class. 7 all over root 52, 62 times root 50. Root 62 is 7.9. Root 50 is root 50 is 7.1, right? By the time you do everything, 7 all over 7.9 times 7.1 is 56. 7 all over 50. 7 over 56 is 1 over 8. 7 here, 1. 7 here. So that cos theta PQ, let's do it here, please, is 1 all over 8. 1 divided by 8 is what? If you do everything very well, theta PQ, make theta PQ so a formula. Let cos come to this side and become cos inverse. Cos inverse of 1 all over 8 will give you 82.8 degree. Please, those watching online, you can pause and confirm these values. You can always pause, confirm these values, but you have 82.8. This is the cosine angle between these two vectors, 82.8 degree. Class, now the sine angle, right? The sine angle between the two vectors. The sine angle between the two vectors. We have 4i plus 5j minus 3k. Class, sine angle between the vectors, say we must first find. Now, instead of a cross b, what will be there? P cross Q, right? Because we're dealing with P and Q in our main question, right? All over magnitude of P times magnitude of this formula for sine angle between two vectors P and. Class, I need to first find P cross Q and find the magnitude. P cross Q means, which one will I? Let me use matrix quickly. I minus J and K. Thank God I don't want to explain. I've taught you cross products. So I can just solve as if I'm in an exam. P, Q. P is 7, minus 3, and 2. Q is 4, 5, and minus 3. I'll form matrix for I component. What will be I component? Minus 3, 2, 5, minus 3. You don't mention members of I, right? Form for minus J component. Don't mention members of J. 7, 2, 7, 2, excluding J. 4 minus. Form for K here. Don't mention members of K. 7 minus 3, 4 and 5. Resolve this. Resolve the I component. Minus 3 times minus 3 is positive 9. Minus 2 times 5. 10 into bracket I. 9 minus 10 is minus 1I. The J component, 7 times minus 3 is minus 21. Minus 4 times 2, 8. Minus 21 minus 8 is minus 29 into bracket minus J, which is plus 29J. So plus 29J plus 29. K. 7 times 5 is 35. Minus 4 times minus 3 is minus 12. Minus times minus. 35 plus 12 is 40. So P cross Q, class. P cross Q. P cross Q is minus 1i means minus I. Or let me put the minus 1. Minus 1i plus 29j plus 47k. Class, the sine theta asks us to find the magnitude of P cross Q. Magnitude of P cross Q is to find the magnitude of this now, of this answer we got. When you want to find magnitude, start with the square. This P cross Q. What is now the magnitude of P cross Q? Magnitude of this answer that is minus 1, or even some of you in this physical class, you need to go and watch it again, Abby. I'm fast. So you need to go and come down and watch it. Thank God. You're in the paid members group. All of you have registered now. If you have not registered after the class, see me and register so I can add you to our paid members group. All these videos, our students that have registered, we're able to access them. Plus 29 square plus 47 square. Minus 1 square is positive 1. 29 square is what? What's 29? Someone should help me, please. What's 29 square? Someone should help me, please, fast. What is 29 times 29? 841. 47 square plus, quickly. You say? 2209. Add it 1 plus 841 plus 2209. 1 plus 841 plus 2209. 3051. Square root of 3051. 55.22. Is that correct, class? Is that correct? Okay, 55.2422. Okay. Class, we've gotten the magnitude of P cross. We have gotten the magnitude of P cross Q. Next thing we need to do now is to, class, we already have magnitude of P because it's the same question we have done before. We got root 62, right? And root 50. So this one, root 62 gave us 7.9. Root 50 gave us 7.1. Class, magnitude of P, we have done it before. We have root 62. Even if we have done it before, you know how to do it. Root 62 will give you 7.9. And magnitude of Q, we have done it before. We got root 50. 50 gives you 7.1. Class, and I have everything to get my sine angle between the two vectors. I now have everything to get my sine angle between the two vectors. I've taught matrix before, right? Take it as a classwork, as a challenge. I've taught matrix. If you cannot solve it, then what are we doing here then? If you still need to copy what I've taught, then what are we doing here? Class, sine theta PQ is equal to, what's magnitude of P cross Q? Magnitude of P cross Q is 55, right? 0.24. All our magnitude of P alone is what? 7.9. And magnitude of Q is 7.9 times 7.1 is 56, right? So 55.24 times 50. Yeah, 55.24 divided by 56 is what, please? 55.24 divided by 56 is 0. Some. 0.99. So sine theta PQ is 0.99. Can we make theta PQ so a formula? Theta PQ is now equals to sine inverse, right? But when sine moves to this side, it becomes sine inverse. So what is shift sine? 0.99. Shift sine. 81.89 degree. 81.89 degree. 81.89 degree. Ladies and gentlemen, we have come to the end of vectors in physics. I will do you guys a favor and I'll post this video for everybody one more time so you can see what you are missing. But after this video, we are going to the tougher part of physics now. If you have not registered with us, you will not be able to access the video. But I will do everybody. If you're watching this video now, it means that I posted it for everybody, all 100 level students to watch. But this will be the last video I'll post for physics, all 100 level. After this video, it will only be for our registered students. We are going to the tougher topics in physics. Topics like rotational dynamics, topics like frictional forces acting on the body, tougher topics in physics that will be dealing with system of particles, momentum and collision, elastic collisions. If you have not registered for our class, you will not get a video. But I'm posting this for everybody, vectors, to help everybody. Please send us a DM so you can register with us. We're expecting your DM. Thank you very much.